Hi everyone. Today we are applying the operations of our radicals to the Pythagorean theorem. We've briefly discussed the Pythagorean theorem. Everyone, I believe, is familiar with the fact that the legs are called A and B, and the hypotenuse, which is the longest of the three sides of the triangle, is C, and it's always across from the 90-degree angle. Pythagorean theorem is such that the sum of the squares of the two legs will equal the hypotenuse squared, or a squared plus b squared equals c squared. So the c squared is always the largest of the three sides, and it is always the guy by itself. So as you can see in all these problems, we have missing legs, and we need to find them. So if you would notice, the variable here on the first one is the hypotenuse. So I always like to write the Pythagorean theorem out and plug in accordingly. So 4 squared, 16, 8 squared is 64 equals x squared. 16 plus 64 gives us 80. So now the objective here. You want to express your answers in simplest radical form. So everyone recalls, I know this, I know you know this, in order to solve for x squared, when it's just equal to one number, the quickest way is to take the square root of both sides. So now you have plus or minus the square root of 80 equals x, and it's plus or minus because the original problem had an x squared, which indicates there will be two solutions. But we're not going to use the negative. We're not going to use the negative because we're talking about the length of a triangle, so that is just going to be dropped. You have to write it though, it's the technicality. So then you have to think to yourself, what is the largest perfect square root that divides into 80? So, any takers, any takers? 4 is not going to work. It is 16. I had to think about that one. So the square root of 16 times the square root of 5, and then it becomes 4 square root of 5, which is the missing leg, not the missing leg, which is the missing side, which is the hypotenuse. So basically, as you can see, this is just more simplifying square roots. Okay, so be mindful of which part of the right triangle you are solving for. The 90-degree angle is always across from the hypotenuse, which in this case, again, is our missing side. A squared and b squared, it does not matter which goes where. What I'm talking about is addition's commutative. So you could have put 3 squared plus 6 squared here, if you would have preferred. So 6 squared is 36. 3 squared is 9 equals x squared. 36 plus 9 is 45 equals x squared. Follow me over here. So we have 45 equals x squared. In order to solve, you take the square root of both sides. Please don't forget you have two solutions here. You have to write that, but we will be dropping the negative because we're solving for the length of a side of a triangle. So the largest perfect square root that divides into 45. Are you getting this yet? Is this getting better? Yes, it is 9. So this becomes 3 square root 5. There's your answer. All right, so we just did two problems where you had to solve for the hypotenuse. Of course, that's not always going to be the case, so why don't we solve for, number 3, solving for the side of a leg. Again, I like to set up the a squared plus b squared equals c squared. So now I have 4 squared plus x squared equals 5 squared. I always tend to read the problem left to right, and then that's how I plug in. Like I said, it doesn't matter if you made this x squared and 4 squared. Addition's commutative, so whatever is working for you. So then I have 16 plus x squared equals 25. So this problem's a little different. Whereas these two problems, as you can see, added themselves nicely over, you got 80 equals x squared. This one over here, 36 plus 9 equals x squared. That's not the case here. You have to isolate the variable. So you're going to subtract 16 to both sides. And x squared equals 9. Don't be a glutton for punishment. Don't set it equal to 0 and factor. Take the square root of both sides. So x equals plus or minus 3. But because we're talking about the length of a side, we're dropping the negative. We're rejecting the negative. This is a special triple. What I'm talking about is 3, 4, 5. If the two legs are 3, 4, the hypotenuse is 5. That will always be the case. And any version of that. So if you multiply all of them by by 2. So that would be 6, 8, 10. That's another special triple. So you can just remember it. We usually write special triples like this 3, 4, 5, 6, 8, 10, and so on and so forth. Those are the common ones. So if you do remember that off the top of your head, you'll have the answer before you actually do the work. And yes, everyone, you do have to do the work. If you know it's a special triple, you always have to show your steps. Okay, so that was solving for a leg. And number 4, here's solving for a leg. Oops, I forgot my 90-degree angle here. So I'm going to write down my formula. So it's going to be x squared plus 9 squared equals 3 squared. And I feel like this is not going to work. Did I write this incorrectly from the lesson? I feel like I miswrote this one. Yeah, I miswrote this one. So we're going to skip this one for the moment. Actually, you know what? Do me a favor. I'm such a pest. I'm so sorry. Make this the 9 and make this the 3. Let's see how this turns out. So then we'll do this. Sorry, everyone. We'll do 3 squared because that's the leg now, and the hypotenuse is 9 squared. So it'll be x squared plus 9 equals 81. Yeah, let's just do this. So then you subtract the 9 on both sides. You have x squared equals 72. Yeah, this works nicely. I obviously wrote something wrong there. The largest perfect square root that divides into 72 is 36. So now you have x equals 6 square root 2. I'm ignoring the negative. I'm rejecting that negative. Okay, so did everyone recover from that? Make this the 3 and make the hypotenuse 9. Sorry about that. Okay, and we're going to solve for hypotenuse again. So a squared plus b squared equals c squared. That is the sum of the squares of the two legs equals the hypotenuse squared. So we have 3 squared plus 7 squared equals x squared. So we're back to, this is kind of the easiest one. 9 plus 49 equals x squared. So you get 58. So 58, let's see. I'm having a brain fart here. I believe this is prime. I'm dividing 58 and 16. 58, I'm like, for instance, try the 9. That doesn't work. 58 divided by, let's see, 25 is not going to work. That's an odd number. 36 is not going to work. So this is prime. So when you take the square root, you get x equals the square root of 58. Plus or minus, but you could cross out the negative there. And the last problem. We have x as a leg, 8 as a leg, and 15 as a leg. So a squared plus b squared equals c squared. I have x squared plus 8 squared equals 15 squared. So 8 squared is 64, sorry guys, and 15 squared is 225. When you subtract the 64 to both sides, you get 161. I'm sorry, at the bottom of the page here. And 161. I'm trying to think. Like, for instance, I'm doing the math here, 161 divided by 49. That is not a perfect square root. That's not dividing evenly. So I believe this is definitely going to be prime. Can you hear my children screaming in the back? Take the square root of both sides. You have x equals plus or minus the square root of 161. And I'm going to reject the negative, so my answer is the square root of 161. So work on the homework. See how you do with the independent practice. Why is this fuzzy? I don't know. And let me know if you have any questions. So we're really, we're actually doing really well. We're making good progress into our radicals unit. I think you're going to love the next topic, she says with sarcasm. All right, be well. Take care, everybody. Bye.